So what do we got tonight? Is it stuff you can verbalize, or do you need to send me pictures of it? Oh, I have no idea where you're at. I can't. At this point, in other words, it's one thing me providing the material during the summer. I can do that. But providing it during your school year, I have algebra is such a broad subject that I have no idea where you're at. So you got to tell me, you got to help me, you got to bring the material to the table. Even if you've just finished a test, look in their book or whatever they give you as to what's coming up next. And then we can work on that. Oh, okay. Yeah, it's really, really tough during the school year for me to do what you ask. I mean, almost, unless you specifically said, do you have any quadratic equations we can work on? Then I could do that. But there are just too many subjects in algebra. Like last week, we worked on direct relationships. Did you ever get to inverse? Did you get to inverse relationships? No, not that yet. Usually they teach those together because they're very similar. So what do you got? Well, I'm going to start with stuff you can verbalize. Okay, give me some problems. All right, what this is a pair of simultaneous equations. In other words, this is a system of equations, meaning the answer for x and y fit both equations. Okay? Now, when you're trying to solve a system of equations, and it can be 2 equations and 2 unknowns, or it can even be like 3 equations and 3 unknowns, and in some cases 15 equations and 15 unknowns. As long as you have the same number of equations as you have unknowns, then you can generally solve it. Okay? Now, this is Systems of Equations 101, the most simplest kind. And with those, you really have 2 choices. You can either do it by substitution, or you can do it by elimination. Now, the format that they gave you these 2 equations in are standard format, both of them. And by standard format, I mean the x and the y are on the left side of the equation and a number is on the right. Okay. I could rewrite this second equation so that it looks like this. And now it's not in standard format anymore. It's completely defined in terms of x. The method you use to solve these is going to be dependent on whether they're in standard format or, I don't know what you call this format down here, but what I call it is one variable is defined. X is 2 minus 4y. There's no x's on the right side of that equation. Okay? So if they gave me a problem that had that as one of the equations, I would use substitution, always, 100% of the time. If they give me two equations that are in standard format, like they gave you, then I'm going to use elimination 100% of the time. So let's erase that and all this other stuff. The important thing to realize is that they are in standard format. In other words, the x's and y's on the left, the numbers are on the right. So we're not going to use substitution, we're going to use elimination. Now, there's a rule in math that says you can add or subtract any two equations, which means I can add those or I can subtract them. Can't multiply them, I can't divide them, but I can add or subtract them. And our goal, let's call this equation 1, this equation 2, and this is not a bad thing to do on every one of these problems. And you'll see why in a moment. Our goal is to eliminate a variable. Now, if I can add or subtract the equations, how can I eliminate a variable? If I add them, I don't eliminate, I get 3x plus 9y. If I subtract them, I get x minus y. But what if I multiplied equation 2 by both sides by 2? And you're always allowed to do that. The rules of mathematics allow you to do anything to the left side of an equation as long as you do it to the right side. That's always an option. Okay? So what we now have is a different equation 2. Since I'm multiplying the left side by 2, gives me that. Multiply the right side by 2, gives me that. Cross it out. This is my new equation 2. Now, with equation 1 and equation 2, how can I eliminate a variable? What do I have to do? If I can add or subtract equations. Okay, so I'm going to do 1 minus 2. So what does that give me? It gives me 0x, which is what I want, because that's going to go away. Okay, what's it give me in terms of y? What's 5y minus 8y? And you got to subtract the right side of the equation also. What's 7 minus 4? What's y equal to? Now we've solved for one variable, and we got to go back and solve for x. Okay? Now, it turns out that this equation right here was probably the easiest one to solve for x given a y, only because the numbers are all small. But I drew a line through it. And I don't really want to plug it into that because those numbers are bigger. You always want to solve for the other variable by plugging it into the easiest equation. So I could go back and rewrite this equation that I crossed out. It was originally x plus 4y equals 2. Well, that's pretty simple. Let's use that one to solve for x. What's x equal to? Do it methodically. In other words, don't try to solve it in your head in one step. Just plug it in. Plug whatever y is. Plug it in, and then solve the equation. That's the way math should always be done. You don't have to come up with the answer in one step. And a lot of students, that's what they try to do, and then they can't do it. And so the key is memorizing the methodology. So if I say that equation is true, and y equals minus 1, how do I get x? Okay, tell me what to write. I mean, you're correct. That is what you do, but I need you to tell me what to write. Because when you're taking a test, you got to write that second step. You can't just explain it like you're doing. That's what I'm looking for. That's what you have to do on a test. Next line. And final line. There's your two answers. Y equal minus 1, x equals 6. Okay? Now, let's go back for a moment. And there's actually a slightly easier way to do this problem. And the reason I say that is because everybody I know has more difficulty with subtraction than they do addition. So instead of multiplying, remember what our original equation 2 was. It was this, x plus 4y equals 2. Okay? And then what we did was we multiplied the bottom equation by 2, right? So that when we subtract them, x would disappear. Turns out that a better step is actually to multiply that bottom equation by negative 2. And the reason is then you produce this as the new equation, which is minus 2x minus 8y equals minus 4. And why is that better? It's because now you're going to add the two equations together. And addition is always easier than subtraction. So this equation's no longer the one I'm interested in. I multiplied both sides by 2. And now I want you to add 1 plus the new 2. What do you get? I want you to add 1 to 2. Give me the whole line. You need the whole line. In other words, what do I write below the line? That's always what I'm asking for when I ask you to give me an answer. And I want you to explain it to me. I want you to give me what the line I write is. I'm adding 7 to minus 4. Okay. Which gives us y equal minus 1. Same thing we got the other way. Now, this problem wasn't a particularly good example of why addition is easier than subtraction, but trust me, it is. And I'm sure you probably agree. You'd much rather look at an addition problem than you would a subtraction problem, right? Yeah, now I'm going to figure out x in the same way that I did before. I'm going to choose one of those equations, plug in y equal minus 1, and solve for x. And I'm still going to get x equals 6. It's just that I wanted you to be aware that if you're going to multiply one of the equations by a number, try to set it up so that you create an addition problem, not a subtraction problem. Okay? Give me another one. Notice standard format, first one, standard format. Second one, what method am I going to use to solve this? Okay, and what am I going to do as a first step? Of which equation? Well, I need all the information. We're looking at two equations there. Each equation has a both sides to it. So you're talking equation 1 or equation 2? Yeah. I'm going to multiply equation 2 by what on both sides? 2. In other words, what I'm trying to do is to get rid of one of these variables. If I multiply the bottom equation by 2, it turns this into minus 6x. And now I got 6x plus a minus 6x. X is going to disappear. That's all we're looking to do. Okay? So I'm going to multiply bottom by 2. Now, that gives me kind of a strange result. It gives me minus 6x plus 2y equals 14. That is my new equation 2. Let's cross out that one. This is the one we're dealing with. Now, how are we going to solve this one? Now we got this equation 1, this equation 2. What am I going to do next? You only have two choices. You can add them or you can subtract them. What do you have? You have 0. In other words, the x's and the y's both disappear. Well, I still got to add 5 to 14. But whenever you get a result that looks like that, that's impossible. You can never have one number equal another number. And what that tells you is that there is no solution to this system of equations. You actually have 3 possibilities when you're looking at a system of equations, okay? You have 1, exact x, and exact y, and that's usually what you get. You get a y value and an x value. But when you try using elimination to solve it, and you get one number equals another number, that's no solution. And a third possibility is infinite number of solutions. And that happens whenever you get one number equals another number. For example, if I give you this, x plus y equals 10, well, that in itself has an infinite number of solutions, right? There's 2 variables, there's only one equation. And so I give you a second equation, but the second equation is merely a multiple of the first equation. It's not really a different equation. Notice that it's just the first equation multiplied by 2. So now, if I go to solve this one by elimination, and I multiply the top by minus 2, and now I add everything, I get 0 equals 0. When I get a number equal to another number, that's infinite number of solutions. And the reason is because I really only have one equation. I don't really have 2 equations. It just looked like I had 2 equations. When your second equation is just a multiple of your first equation, you don't have 2 equations, you have 1. What you need is 2 independent equations. Okay? Now, something like this, That looks a little strange, but it's entirely possible that that could be true. Solve those two. Tell me whether you're going to use elimination or substitution, first decision. And are you going to add or subtract the equations? Okay. Add those two equations, what do you get? No, you got to add both sides. In other words, if I'm going to add the left side, I got to add the right side. I cannot add just the left side. Okay, which x equals, if x equals 10, what's y equal to? And notice that works. 10 plus 0 equals 10. And down here, 10 minus 0 equals 10. So that solution works for both equations. So even though this looked strange, the fact that x plus y could be equal to 10 and x minus y could be equal to 10, it in fact does have a unique solution. And that's what it's called when you get a specific value for x and a specific value for y. That is a unique solution, as opposed to no solution, as opposed to infinite number of solutions. Now, this is actually a key part, unfortunately. You're going to have to know this when you take your SAT. One of the harder questions on the SAT exam involves this concept. All right, what else you got? Substitution or elimination? What's the next step? Okay. And then to me, I like running a line through that, because it tells you that these are the two equations you're now dealing with. And sometimes when you have three variables and three equations, you end up with equations all over your page. And if they're not numbered, it's really confusing. So it's not a bad idea to learn this in the simple type equations like we're dealing with here. Okay, now what are we going to do? We have two equations now that look pretty easy to eliminate something. What am I going to do to those two equations? Add or subtract? That's the next question you always have to ask yourself. Okay, what do I get? Okay, now what? I still got to solve for x. Now this is one of the unfortunate parts about me drawing a line through this equation, because if you're really trying to solve for x, the easiest one is this original one. Notice the numbers are all really small. It's 3x minus y equals 2. So that's the one I want to use. In other words, I could use this one, I could use this one, but they all have bigger numbers. And another rule in math is if you want to get the correct answer, use the smallest numbers possible. Well, there's no number bigger than 3 on this one over here. So solve this equation right there for x, given that y equals 2. Good. Good. Perfect. So there's your x value. There's your y value. And that, if your life depended on it, if somebody had a gun to your head and said they were going to blow your brains out if you got it wrong, what would be the next step you would do? No, I would substitute and make sure both of those answers work in both equations. Okay, in other words, if I choose this here, let me change colors so you can see where I'm pointing. That's my first equation. Well, let's see if that is true. X is 4/3. Y is 2. Is that equal to 2? Well, the 3's cancel, and you get 4 minus 2 equals 2. So yes, that one works. Okay? I'm not telling the person the answer with the gun to my head until I check the second one also. Now, I got 6 times 4/3 plus 3 times 2. Is that equal to 14? Again, that 6 cancels with the 3 and leaves a 2 behind. So you have 2 times 4, that's 8. Plus 3 times 2 is 6. 8 plus 6 is 14. Bingo. So our answer works for both solutions, or both equations, rather. Now, let me add one more comment. If you are taking a test, speed is usually a factor, correct? Yes? No? I mean, aren't you always on a clock? Always? Do you ever get to take a test that you're not timed on? Okay. If you're not timed on a test, then I would do this step where you check your answer and make sure that it works for both equations. And by both equations, I mean that one and that one. That was the original number 1 and number 2. If you're being timed and speed is a consideration, then you don't necessarily need to do this step. Nobody's got a gun to your head threatening to kill you. So you're 99% sure that that's the correct answer and that's the correct answer. And if I was taking a test, I would go to the next problem. I would not check my solution. Understand? Okay. And you're going to take a lot of tests that you will have to consider speed. So sometimes you want to check those answers, sometimes you don't. Sometimes maybe you want to just check your solution in one of the equations. In other words, once you check it in one of the equations and it works, you're pretty darn sure that it works in the other one too. So if I really had time to check, I would check it in one of the equations at least. All right, what else you got? Got anything that uses substitution? And what we're looking for to use substitution is where at least one of the equations is not in standard format. Okay, let's do the next one. I'll show you how to use substitution. It's silly to give you those instructions on those 3 problems you get. That truly is silly because you're never going to use substitution on that. You're always going to use elimination. So if they want you to use substitution on a problem, they should give you one of the equations so that it's like, here, I'll make one up. That's in standard format. But if I tell you y equals 2 minus x, that's not in standard format. So when I have standard format and I have, let's call this regular format, I'm never using elimination. I'm always using substitution. The reason being is that this equation is defined in one variable. They have told me what y is equal to. So I'm going to use substitution 100% of the time here. How am I going to do it? Well, you're going to take this and substitute it into that one. We know what y is, right? Okay, so what comes out next? 4 times what? Here's what y is, right there. Y is 2 minus x. So that's what goes there. Now, notice what we end up with. One equation, one variable. That means I can solve for x all day long. Solve this equation. What's the next line? Keep going. Good, 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 good. Okay. So what's x equal to? No, negative x is equal to 4. So how do I get rid of that negative sign? I want to solve for x. I don't want to solve for negative x. Yeah. In other words, what I'm going to do is divide both sides by -1. That -1 cancels out with that negative, and I'm left with x. 4 divided by -1 is -4. So if x is -4, what's y? And this one's a lot easier to do. When one of the equations is fully defined for y, now this becomes a piece of cake to solve. If x is -4, what's y? And always use this one. You could solve it by going up to that one, but the algebra, the arithmetic's a lot harder. This arithmetic is one step. What's y equal to? Good. So y equals 6, x equals -4. That's a unique solution. And I use substitution because both equations were not in standard format. That's pretty much the rule you use. If both equations are not in standard format, then you always use substitution. If I gave you something like this, what are you going to do? Substitution or elimination? You only use elimination when both of them are in standard format. Every other situation, you use substitution. Are either of these in standard format? Okay. What's the next thing I'm going to do? This is a little unusual. We haven't seen something like this yet. But the thing to know is that whatever the solution is, that x is the same as that x, and that y is the same as that y. So if these two y's are the same, what else is true? This is equal to this, right? If they're both equal to y, and the y's are the same, then I can say 5x plus 2 equals 4x plus 5. Now solve that. Yeah. I usually do this step in one step. And what I do is I gather all the x terms on the left side, I gather all the numbers on the right side. I don't do it in two steps. I do it in one step. That's the one place where I kind of advise doing it in one step. Okay, so those are your only possibilities when they give you two equations, when they give you a system of equations. They're either going to give you it where one of them's in standard format, one of them is in y equals mx plus b format. You know what I mean by that? That is in y equals mx plus b format. What I previously called regular format. This is the format that you'll deal with in most of algebra, where it's y equal mx plus b, where b is the y-intercept, and m is the slope. We know it's a straight line because it's a linear equation. All linear equations are straight lines. It's only when you get to quadratic equations, where you have like an x squared, that it becomes a parabola, or any kind of a curved line. If you had x to the fifth, might be a really curved line. But anytime you have x to the 1 power, and it's equal to y, and it's in this format, that's a straight line. And you figure out, you can know how to plot it real easy. The y-intercept comes at plus 5. The slope is 2. There's the graph of that equation. And know how to do that. That's Algebra 1. That is the basic, that's the most basic thing in Algebra 1, is how to graph a linear equation that is in, this is actually, it's not called y equal mx plus b format, it's called slope-intercept. Because they give you the intercept, which is plus 5, and they give you the slope, which is 2. So when one equation is in slope-intercept and the other equation is in standard, use substitution. If both equations are in standard, use elimination. And if both equations are in slope-intercept, use substitution. Just realize that that y is equal to that y, which means this has to equal that. So I've probably covered all that you were given on homework, but so far the only ones you've given me are the ones that elimination. I know the instructions were to use substitution. Well, let's give me a fourth. Do you have another one that we haven't done yet? Give me that they want you to use substitution on it. Go ahead. What's the first one? Doesn't matter. You can give me one we already did. I'll show you how to do it using substitution. Now, this is actually hard to do with substitution because I've got to manipulate one of the equations. So let's manipulate this one. This one's not too hard to manipulate. I can turn it into an equation that's not quite in slope-intercept form, but I don't need it to be in slope-intercept form, because all I need is one variable to be solved. And I've solved this for x. It's the easiest one to solve for, okay? I could have solved for y, but then I would have had to subtract x and divide both sides by 4. Would have been an additional step. So I've put one of the equations in not quite slope-intercept form, but close enough. I don't need it in slope-intercept form. I just need one variable solved, and I've done that. So what's the next step? In other words, I've crossed that one out, and this is the same equation. The only keep going. Okay. Hold on, let me erase. Now what? Hold on, what's 2 times minus 4? Keep going. Next line. Okay, at this point of an equation, you have to decide which side you're going to put your variable on and which side you're going to put your number on. So which side are you going to put your variable on? Okay, so what is the combination of that and that? That's what you have to combine. And what's the right side going to be? And again, we get the same solution, y equal minus 1. Okay? Now, because we actually have one of the equations in this format, it's pretty easy to solve for x, right? So all we got to do is substitute minus 1 for that. So you get 2 minus 4 times minus 1, and that again is equal to 6. So the difference between using elimination and substitution required an extra step. In other words, to use elimination on this was easy, in my thinking, than using substitution, because to use substitution, you had to solve one of these equations for one of the variables, and then go in and solve it slightly different than you would with elimination. But in my thinking, I always, 100% of the time, use elimination when I've got 2 equations in standard format, and any other combination, I use substitution. So for them to tell you to use substitution on these 2 equations that they gave you in standard format is ridiculous. It's just not the way you would do it. So what else? What else you got? Okay. Here's equation 1, equation 2. And they actually want you to use elimination here. Yeah, because that's in standard format, and this one's in standard format. Not only that, but I can eliminate a variable really easily without even multiplying either equation. What do I got to do? Okay? I don't mind subtracting, it's just don't make a mistake. It's easier to make mistakes when you subtract. So what do you get when you subtract these 2 equations? Good. Simplify. Well, what's 8 over 16 equal to? 1/2, not 0.5. I know you got 0.5 by doing it on your calculator. It's 1/2. 8 over 16. You're going to divide the top by 8 and the bottom by 8. It gives you 1 over 2. And the reason that's significant is because I'd much rather that say 1/2 than 8/16, because I got to choose one of these equations and plug that in to solve for x. I'm not done with the problem yet. Which equation would you choose? Yeah, I don't think it makes a whole lot of difference. I usually try to choose the one that has the smallest numbers. Well, 6 is smaller than 10, 17 is bigger than 9, half a dozen of one, 6 of the other. Okay, so I'm going to use this equation here, solve for x. Well, let's do it like this. 2x plus 6 times 1/2. Here's a place where I don't really want you to skip a step. It's when people skip those steps that mistakes start coming out of the woodworks. It's unbelievable. So to avoid making a mistake, do the first step. That's always what you're doing. Now, okay, now you can simplify and turn it into a 3. Now you can say 2x equals 14, and you get x equals 7. And there you have a unique solution for x and a unique solution for y. And again, if they said your life depended on that answer, you go back and plug it in at least into one of them to make sure that it was a true statement. In other words, is 2 times 7 plus 6 times 1/2, is that equal to 17? And yes, 14 plus 3 equals 17. So it works for one solution. I've never seen one that works for one solution and doesn't work for the other, although I suppose it's possible if you have one of those no solutions or infinite solution problems. But when there is a unique solution, check it for one of the equations. If it works, you're good to go. What else we got? Have they given you one that has 3 variables and 3 equations? Okay, because those are a little tougher. There's a methodology you have to follow for those, and they're definitely tougher. And whether they'll give you one or not, I don't know. When they do, tell me about it, and I'll show you how to do them. 2 equations with 2 variables, you're either going to use substitution or elimination. Sometimes they'll tell you to solve it graphically. In other words, when you have 2 equations, it's 2 linear equations, and the answer is where they intersect. Always. So if you can figure out how to graph each equation and then read the intersection point, whatever the x and y coordinates are at that intersection point right there is the solution. So that's the third way to solve simultaneous equations. It's not a particularly good way because if it's not perfectly on a grid line, it's hard to read what the answer is. If it's 3.17 as an answer, you're not going to be able to read that off of a graph. So I don't particularly like the graphical method, but I suspect they're going to teach it to you just because that's the new method of teaching math, is to make sure you know how to do it algebraically, numerically, and graphically. What else you got, Brandon? And what do you notice right off the bat here about these 2 equations? What do you notice that's similar? The bottom equation is merely a multiple of 2 of the top equation, which means it's not any different. I could have generated this one all on my own without them giving it to me, which means I really only have one equation. And when you have one equation and 2 unknowns, infinite number of solutions. So the fact that they've given us a second equation that is merely a multiple of the first one is not a second equation. In other words, if they didn't give me that, I could easily write it myself. I can multiply it by 3 if you like. It does not matter. If I'm just doing a multiple, then I have not. That's not a new equation. And if I use any method that we've talked about to try to solve this, I'll get 0 equals 0. And when you get a number equals the same number, it's infinite solutions. When you get a number equal a different number, that's impossible. That's no solution. So merely by recognizing that equation number 2 is a multiple of equation number 1 immediately tells us that it's infinite number of solutions. Now, if I actually tried to solve this, in other words, if I didn't recognize that, well, let me take the one I wrote, merely because I haven't scribbled through it. Let's take this one. Okay, let's say I give you these 2 equations, and you don't recognize that the bottom one is just a multiple of 3 of the top one. So you go to solve it. Well, you're going to use elimination. What are you going to do? You're going to multiply the top by minus 3. You're going to multiply the right side by minus 3. It's going to give you this equation, minus 12x plus 9y equals minus 30. You're then going to add those 2 equations, and you're going to get 0 equals 0. Whenever you get, it doesn't matter if it's 0. It could be 1 equal 1 or 5 equal 5. But when you get one number equal another number, it's always that infinite number of solutions, because you don't really have 2 equations. You only have 1 equation. And 1 equation, doesn't matter what it is. If I tell you x plus y equals 10, that has an infinite number of solutions. Notice x could be 1, y could be 9. X could be 2, y could be 8. Now if I introduce negative numbers, x could be minus 1, y could be 11. X could be minus 2, y could be 12. I can go on forever. So because I have 1 equation and 2 variables, I have an infinite number of possibilities for solutions for x and y. And merely giving you a second equation like this doesn't help. Doesn't give you any more information. I still have to have an infinite number of solutions. Okay. Yeah, we got 5 minutes. Is there anything else you want to go over? Okay, all right. Now these are probably the tough ones, like the last one you gave me. That was the toughest one they've given you so far. So. All right. Glad they gave you one like this. Notice that we cannot multiply one equation only by a number. I can multiply it by fractions, but you don't want to introduce fractions into this. I don't want to multiply the top equation by 3 halves in order to get a 3x or negative 3 halves. I just don't want to do that, because then that'll give me a fraction where the 5y is, and it'll give me a fraction where the 14 is. So there's a better way to go here, and that is to figure out a number. Remember equations. I can multiply the top by any number that I want, and I can multiply the bottom by any number that I want. So what should I multiply the top by? Think common denominator. Yeah, think common denominator. What is the least common denominator between 2 and this 3? It's 6. So I want to multiply this by something that gives me 6. So I'm going to multiply the top by minus 3, and I'm going to multiply the bottom by plus 2. Now that gives me two complete different equations, but it makes the problem a lot easier. Minus 15y, I got to multiply that by minus 3, so that's minus 42. I'm going to do the bottom one by 2, that gives me 6x minus 4y equals minus 72. And now what am I going to do? Now it's a piece of cake. In other words, now I've got both equations in a point where I can do what to eliminate a variable? Add or subtract. That's always the answer. It's either one of those. Okay? It's going to give me 0x minus 19y equals minus 114. And I got minus 19y equals minus 114. I'm going to go out on a limb here and say that answer must be... It's not a whole number, is it? What is 114 divided by 19 on your calculator? Here's where it helps to use a calculator. Is it? Oh yeah, it is a whole number, yeah. And is it positive or negative? How am I going to solve for x? Which is the easiest equation of the four equations you're looking at? In other words, you can use this one, this one, this one, or that one. Which one has the smallest numbers? Oh, here's the 2x and a 5y and a 14. The second one has a 3x, a minus 2y, and a minus 36. I like that one better. Before I multiply by minus 3. I don't need to use the minus 3 multiply, but I'm going to be able to solve that one really easy. I know y is 6, so what do I got? 2x plus 5 times 6 is 30 equals 14. X equals negative 16. Or 2x equals negative 16. X equals negative 8. So you got x equals negative 8, y equals 6. So always use the equation that has the smallest numbers. In other words, you wouldn't want to use this one down here. My God, that's got a minus 42 in it, a minus 15, a minus 6. Whereas these numbers are all pretty small, 2, 5, and 14. Just make sure that you use the original one, not the one that I had multiplied by minus 3 on both sides. That's this one down here. You could use that one. You'll still get the right answer. It's just the math will be a lot harder because you'll have bigger numbers. Okay? All right. Good place to stop. Brandon, I will talk to you next time. You have a good week. Bye-bye.